Good evening. I want to start. We're going to talk a little bit about Chapter 5, which is presenting data. So, general outline, we're going to talk about the concepts, about the principles of map design, etc. And then we'll talk a little bit about ArcGIS and what you can actually do in the software. So, let's talk about the concepts. Basic principles of map design. Map design is very much an iterative process. You come up with some sort of objective, what it is you're trying to map. You select data, you arrange that data, you symbolize that data, and you review it, you edit it, and you use that to select more data, all the while feeding back in and off of the objective that is at the heart of why you're trying to make your map. So the map objective is really important. It's the first important design step. 4 key questions to answer. What's the purpose for the map? What's the audience? What is the medium? And under what conditions will it be viewed? And how you answer these questions will determine a great deal about how you should develop your map, what should be in it, and how it should look when it's done. Maps serve many purposes. You can use it for locating things, it can be for navigating, compiling, convincing people, comparing one location to another, analyzing some pattern of phenomena that's occurring, or any number of other things. So let's talk about the audience. Who will be viewing the map? What is their expected level of knowledge about the subject matter, about maps in general? Do they have special requirements? Are they colorblind? Do they need large print? These are the kind of questions that you need to ask in order to generate the proper map. You need to know the audience, because that's going to determine a lot of these situations. The medium. Is it going to be a paper map? Is it going to be something that's in a report? Or are we talking something large scale like a wall map or a poster? Is it going to be delivered electronically, a PDF or a GIF or a JPEG or whatever? What's the format? What are the file size limitations? How are you going to deliver it? Will it go on an email? Is it too big to be emailed? Is it going to fit on a computer screen? What size screen? What type of computers? What type of projection are you going to use? Is it going to be used or seen on mobile tablets or devices or smartphones? All these questions are important, because if you're making a map for a smartphone versus a poster or a wall map, you have very different requirements in terms of what goes on the map and in terms of how it should look. So you need to design for the medium. Posters or paper maps should be static and unchanging, fixed paper size and scale, high resolution. You can have a lot of complex information, and a lot of times you can have a lot of levels of information. Because the viewer's committed, and it may serve multiple purposes. In other words, you're going to have this large map with a lot of information, and somebody is interested in it because they stopped there specifically to look at that. And you could use this for multiple scenarios. Whereas a web map is interactive, it's viewed by a lot of people on a lot of different devices. A lot of times poor light or sunlight can affect how mobile devices look. Generally we're talking about viewers with shorter attention spans. It competes for attention because you're only a click away from going to something else. And so web maps should do one thing really well, and that is highlight that piece of information that it was designed or developed to showcase. So again, we go back to this iterative process of how we're going to develop our map. Let's talk about selecting the data layers. A good map tells a story. It tells who the lead players are, what layers play a supporting role. Do some of the layers distract from the story or obscure it? So if we look at these maps, or these mapped images rather, on the right here, there's different data layers that you can be using to showcase this. And simply by taking and changing how transparent a particular layer is, you can make or not make the data that's represented by these variable sized points obscure or prominent. And so that's important to understand that the data layers that you can easily differentiate and see need to be the data layers that represent the variable or the parameter of interest. Should you omit some data? Privacy issues, publishing parcel owner names. Well, for example, in situations like that, you have to think about the data, who owns the data, and what right you have to disseminate that data. And obviously, if it's something like that, then maybe parcel name shouldn't be attached. Is it sensitive information? Fossil or archaeological sites, because people could come in and dig up when scientists aren't around and steal items. Pipelines or climate stations, vandalism is a concern. Maybe eco-terrorists come in and disrupt an oil pipeline, or maybe a bunch of hoodlum kids come up and knock the solar panel off of some sort of a weather station. Unintended economic consequences. If you point out faults in prospective parcels, then folks who are looking at, for example, where to buy houses, and they realize that your map identifies the area that they're buying a house as an area with a high risk of radon, it may make them reconsider. Publishing water test results for private wells could be an indication of a contaminated aquifer underneath a region, which could have pretty dramatic economic impacts on all the surrounding area. So you have to think about these things and decide whether what you have to map and what data that you're going to disseminate, whether it's germane to your cause, and then use your best judgment. Selecting within layers. Sometimes there is a need to simplify a data set for better performance on a map. This is known as cartographic generalization. You can adapt large-scale data to a small-scale map, and all these things are important to figure out what you need to do to make the data tell a story. So we're going to look at the idea of using a query. So we're going to show a subset of features. If you look at all these earthquake data, everything over 4.0 is identified by a point value, and the larger the point, the larger the earthquake. And it really makes it, in some respects, obscure to figure out where the large earthquakes are at, because you can't tell for the number of small ones. But similarly, if you were to look at just the quakes over 6.0 in the image on the right, that subset it indicates that you might mistakenly think that only earthquakes occur right at the edge of the coast of Chile, when in reality, if you look at the one on the left, there are a lot of 4.0 earthquakes that are occurring further west. And so not only is it important to look at subsets, but you also have to make sure that the audience understands the limitations of the data that you're showing them. In other words, they know that just because you're showing all the quakes greater than 6.0, that there are other earthquakes in other locations, but just not at that magnitude. Other ways that we do cartographic generalizations, we can refine our data. In other words, we can sort of simplify things and make it a little more explicit. We can also simplify really complex lines into straight segments. We can aggregate disjointed elements into composites. We can take unusual shapes and collapse them into more fundamental or basic shapes. We can reclassify things so that some items that would have otherwise been separated become a single unit. We can describe it in different ways. You can displace or you can exaggerate features. There's all kinds of generalizations that you can do to make the data better at telling the story. Another thing that can impact how we do this is selecting a projection. If you use a geographic coordinate system to map the United States, for example, it appears very much distorted. So you always want to use a projected coordinate system when you're mapping. Types of projections. A cylindrical projection preserves shape and direction, so if that's what you're interested in, that's what you do. If you're talking about distance and area, then you probably want to look at something that's more conic. Azimuthal is also really good for distance and area, but only in that areas that are most proximal to where that plane contacts the geode. Unintended consequences. So projections can distort things, and projection choice may affect the story. Mercator maps make northern hemisphere look more important. So if we look here, we have two different map elements, and if you look at the size of Greenland versus Africa, it just doesn't make sense. But you have to realize is as you move into the northern and southern latitudes, the spacing between the lines increases. In other words, it makes those regions artificially look much larger than what they are. So when we look, what's the story on a location like this? There's lots of things going on, but it might be hard to tell because you don't really know. Graticles are grids that are placed on a globe, and you use them with projections because some projections distort direction. So you might have a map that's mapped out using a particular projection. You throw a north arrow on there, which direction does it point? Well, that's difficult because north varies depending on where you're at on the map. So that's where you would put these lines on to show the direction of north. Other types of maps, measured grids, things like the UTM meters or the reference or just a standard reference grid, are both other types of ways. So let's look at how we arrange the data. There's a visual hierarchy. The order in which a reader perceives the different objects in the design can impact how the message is received. In other words, if there's data that's most important, you want to place it within the map in a context that will be identified more prominently by the reader. A good map establishes a clear pathway that highlights the important aspects. In other words, if elements of your map detract from the message you're trying to make, they're not good elements to have included, or at least not included in the way or the fashion that you included them. So look at the map on the next slides for a few minutes, then we'll talk about them. So let's just look at what all we have here. We've got a nice map with a small insert down there identifying the general region what we're talking about. We have a legend that shows us our state capitals, and we have a varied color ramp that tells us the number of people per square mile, and then we have volcanoes that are relative in size by the number of known eruptions. So the visual hierarchy, what was that map about? What did you notice first? How did your eyes move around the map? How was the path achieved? When I think about that map, the first thing that pops in my mind was the size of the volcanoes and the number of eruptions. Secondary to that would be where we're talking about in the U.S., and the third element would be the number of people per square mile. So if we were looking to map the risk to people, in other words the number of people per eruption, there might have been a better way to do that. It just depends on what you're looking for. And so I tended to go for the large darker elements first, followed by the color differentiation that we've seen within the man-made confines of the counties, and then the holistic concept of what it was talking about was the last thing that I looked at. So establishing a visual hierarchy, its visual centers, rules of thirds, balance, alignment, negative space, neat lines, symbolization, color, contrast, size, thickness, foreground, background, they're all important components, so we're going to talk about them a little bit. Visual center is higher than the geometric center. In other words, where you look at in a map isn't exactly the middle of the map, if that makes sense. The rule of thirds, it's the basic rule of composition. Whatever you really want to take a picture of, you don't stick it in the middle of the map. If you've used a camera and you've tried to take good pictures, you know that you want to put your features either in one of the outside thirds, not directly in the middle, because you want to not necessarily frame your feature with everything else. You want to try to do it in a fashion that allows you to show other elements. Alignment, you want to use columns and align the edges so that things work nicely and neatly and look professional. Negative space, you want to balance it out evenly. You don't want to crowd elements together, and you don't want big empty spaces. Use another design element if you have a big space that you have to fill. Look for subtle ways to group things that make it better. So if you look at these two maps, median rent by county, maybe Alaska or Hawaii or whatever those parts are up and to the left aren't that important for the purposes of what you're doing. But if you reconstruct your legend components and you're referencing things in boxes alone to the right, it allows you to make a bigger map in a landscape format and get the other elements in, and you don't waste your white space, and you end up with a much easier map to read. Balancing your elements out, it's all about trying to get it figured out so that the map doesn't look heavy to one location. So it's looking how we symbolize data. Symbolizing for hierarchy, what stands out, what's achieved. So we adjust the color, the contrast, the foreground, the background, the size, the thickness, the symbol, the font, the space, and the grouping. And we do all these things because what we're looking for is a clear hierarchy, something that we recognize, like darker colors are higher, lighter colors are lower, thick lines are more prominent or bigger, thin lines are smaller or less significant. Larger symbols mean more, that sort of thing. Symbols and patterns. The brain doesn't just observe, it tries to find patterns. We have the most sophisticated pattern recognition system in the world, and it is our eyes and our brain working together to identify patterns, because patterns are so significant in terms of how nature functions, that we look for things that repeat and reoccur so that we can predict the future from what we've understood or seen or witnessed in the past. And so very much we are geared through generations of evolution to identify groupings that appear to be significant or correlated. So do you make things stand out and belong together, show differences in quantity, you can show differences in categories. There's lots of ways you can do it, but you need to figure out if it's a pattern you're trying to symbolize or if it's a pattern that's created artificially. There's lots of ways to look at this stuff, but it all comes down to using the tools that you have at your disposal to symbolize data, to highlight the patterns that you're trying to identify or showcase in your map. Which map has a clear visual hierarchy? That would be the bottom one, because the top one, it's really hard to identify what's going on because of that blue background for the oceans, because it's just too blue. So for me, it's the bottom one, because the top one just makes it so difficult to deal with. Base maps. How does this base map establish visual hierarchy? Well, there's a couple of ways. One, you notice that the size of the font for the locations identify more prominent cities by using a larger, bold font. Same way with the roads, you see darker lines for the highways, and then you have other less prominent roads. Rivers are the same way. Larger streams are larger, smaller ones are smaller, etc. Reviewing and editing. When you review the draft of a map, there are certain things that you're going to look for. You're going to check the balance. You're going to look for visual hierarchy. You're going to print to check colors on a paper map, spelling, grammar, details, and do you remember to cite the sources of the data? So some things to look out for. You don't want things to be crowded near the edges of a box like that. And you need names that are not. You don't want names to be unclear. It's easy to write so most people understand it, but what you need to do when you're labeling things is write so that nobody can misunderstand it. And be very careful with using abbreviations, because others may not know exactly what you're abbreviating to or from. So you want to make sure that you have clarity and purpose in the details. So we'll look at another map. Household size. We got a lot of things going on here. I can tell you offhand, this is not a map that I really like. There's a lot wrong with it. I don't like that gigantic shadow on the title. The title is too small. It's poorly placed to eat up white space. We can't tell anything about that stuff up there and to the left. Likewise, our collar ramp is horrible. We can't see, do we really need to know where the Great Lakes are? Isn't that kind of self-evident? That little text box is really not telling us a great deal. Anyway, a lot of stuff wrong. So here's another one, household size by county in the United States, 2012. Very clear title. Not a lot of wasted space. The map tells us some information about where things came from at the bottom down there. That's good. The color ramp is easy to understand. Low colors light, high values dark. Much better representation. External review is a very good opportunity to make a better map. And essentially what we're talking about here is, and this happens to a lot of people, whether you're writing a story, a report, or a dissertation, you get what I call writer's blindness, in that your brain reads things the way you intended it to state. And so simple mistakes in grammar, spelling, sentence structure are automatically resorted by your mind to say what it is that you wanted to say, as opposed to what you actually wrote. And so it's very helpful to have other people review things, because they don't have those determined prejudices about what you did, and so they simply look at it and evaluate it, and they can help you see if there's things that are wrong. So people similar to the intended audience are a good choice for external review. People in your field that understand what's going on, or a graphic designer, if you have access to one, can be very helpful in making good maps. 3-second test. Look at the map on the next slide for 5 or 4 seconds, and see what you think of it. We've got 4 or 5 seconds here, so look it over. Okay. Now, what was the first thing you noticed? What was your first impression? Was it positive or negative? What made you feel that way? Now have a look for a longer period of time and see what you can come up with. So take a few minutes after you're done going through these slides, or listening to me go through the slides, open up the PowerPoints and look at that, and you'll see that what we're mapping out is, and what you're assuming it to be, may not be the same thing. And so you need to take a look at that and see if you understood that map in that short, brief period of time. Longer review. After a longer look, think about the map, what it is, what's the main points, is anything confusing or unclear. So when we're editing and trying to improve on a map, how do we do that? Well, you want to concentrate on the message. Ask yourself, what's that one thing? There's an old adage they're saying about, if you really want to know what's important in life, ask yourself the simple question, what's the one thing you can't do without? And once you figure out what that is, everything else kind of falls in place. And it's the same way with a map. Concentrate on the message in the map. What is it you're trying to infer? What information are you trying to disseminate? What message are you trying to send? Focus on that and make sure that everything about that map is to the betterment of that cause. Simplify your map. Complex maps with complex information set about in complex schemes to represent complex stuff just gets too complicated. So you need to make sure that you can simplify it so that you can distill the message and get it across to your users effectively. Experiment. Try multiple kinds of maps. Don't fall in love with a certain style of map. I've always made maps this way. This is great map making. This is what I'm going to do. Don't be afraid to try something new. Maybe graduated symbols is the way to go. Maybe graduated symbols is not the way to go. Try some of the other techniques until you find what fits and what works. Test under conditions of use. Essentially, you create these maps and you think you might know what's going on, but once you talk to people and you have them take a look at your maps, don't be afraid to then go back and say, this isn't working. It's not doing what I wanted it to do. How can I revisit my choices to make a better map? So that gets us around sort of back to the end where you're done maybe after you make those edits, but in reality you may not be. It just might lead to the selection of more data and going through the process one more time. Okay, so now we're going to talk a little bit about ArcGIS and what some of the software can do. Page layouts and map skills are something we're going to look at. Map layouts are basically the hard copy maps that are generated in ArcGIS. So after you actually make visible the things in your ArcMap window, if you switch to map layout view, this shows it as the way the map will look if printed and when printed. And so when you create hard copies of map, you need to consider and remember things like placing titles, legends, scales, north arrows. You need to include tables and graphs in a map. You got to do that in this view. And similarly, you might use this as an opportunity to add images or colors or logos. And all depends on what kind of map you're making, what you're trying to tell story-wise, who the map's intended audience is, and the purposes that you're making it. All these things go in to how you best choose items. So the layout toolbar, I'm not going to go over what each of these tools do, but you can see there's a lot of things there that you can adjust and look at. You can zoom in and out. You can zoom in and out on the data or on the layer as a whole, and so you need to look around with that a little bit. So the steps to layout: you want to plan your map, you want to set up the map page in the data frames, add a legend, add a scale bar, add titles and text, add objects, and neat lines and backgrounds, graphics, and then you want to print the map. So a couple of things that you need to do when you're visioning out what this map should look like. Paper size. Do you want to put it in landscape or portrait? So looking at the area you want to map can really help, because that'll give you an idea whether it's just naturally inclined, more upright, or more horizontal. You want to think about the margins of your map, make sure that you're using good spacing, and you can use grids or align features to get these things squared away. So lots of ways you can set up a map. You can use a predefined map template when you're starting, or you can use a blank map. Lots of different ones. You can switch to another template after a map's been created as well. And so you can assign frames, and then you can order your various data frames in your map to the various frames that you have listed on your map layout. So you can always go to page and print setup and look at how it's going to present your map, and then check it out. You might have to go in and do some work with your composing your frames and adjusting things, or set the size or location for how stuff is supposed to look. You can automatically scale things to resize. You can use a fixed scale or a fixed extent. There's lots of options. Units terminology: map units are determined by the data frame coordinate system. Display units can be set by the user so that the coordinates may be viewed in any desired units, such as miles or feet or millimeters, or, as my personal favorite, if we're talking about map scale where it's a ratio and it's unitless, it can be 200 aardvarks to 100 aardvark. It's still 200 to 1. Page units show the location on the map page layout, and it's usually in centimeters or inches. So the scale bar shows the current scale as you zoom in and out. The map units, if you check on that, tells you how things are displayed. And then down at the bottom, there's another window that displays the current cursor location in terms of its actual coordinates. So when we look at setting up the display units, you go to the data frame properties under units, and you can adjust those to whatever it is that you want, and that will change what shows up at the bottom of the screen. Doesn't change any of the things related to projection, simply changes how the data is displayed in terms of the display units. Labeling and annotation: dynamic labeling, which is introduced in Chapter 2. Layer properties are set for each layer. They're placed automatically for an entire layer. Graphic text is simple graphics placed and edited on layout. It's saved as part of your map document. Annotation is usually created from dynamic labels and can be saved and edited for exact placement, so you can move it around a little bit if you need it. It can be very helpful that way, because a lot of times the straight options that we have in terms of labeling things don't always label very well. So under the Labels tab, you can click the little box and label features in the layer. You can select the fields that you want, change the font size, the color, and the symbology, as well as where it's placed and other things. So just some ideas here. If you go to this graphic text must be placed in the layout view. So if you're not in the layout view, you can't see it. It allows you to put in things like callouts or spline text or new text if you want to add messages. You can also adjust the character spacing and how things are aligned when you add multi-line labels and things like that. The label tool must be used in the data view. Okay, so that's a little bit different. But the label tool creates a label from the display expression field in the attribute table when you click on a feature. So as you go over it, it'll show those things. Annotation can be created from dynamic labels, then edited individually. It provides precise control of each label and can be stored in one or two ways. Text in a map document can be used only within that map document. Simple editing using the draw toolbar, and it can be added as a feature class in a geodatabase. In other words, you can have the labels of the locations, and use that almost like it's a layer file of just labels. And so maybe you want the cities, but you don't want the points, the dots. You just want that dynamic label of what the place is to show up in the general area. Default labeling scale, size of labels and symbols are specified when they are created. By default, they remain the same size as the user zooms in and out. If specified as 10-point labels, they are always 10-point labels, no matter whether you zoom in or out. But the thing is, if you zoom out too far, the number of places and their spacing on the map become closer, and then maybe the 10-point is not really what you need. Reference scale, alternatively, symbols and text can change size when the user zooms in and out. The reference scale is the scale at which symbols will appear at the assigned size. If the reference scale is set, then symbols and text change size when the map scale changes. They only appear at their assigned size if the map scale once again matches the reference scale. So to create annotation, you can use the convert labels to annotation feature. It's one way. You can set up the dynamic labels with desired properties and turn them off from the layers. Turn off labels for layers that should not be converted to annotation. So the convert labels to annotation, you can store it in the map or in a database. Unplaced annotation is put in an overflow window. Users place each label individually or it deletes it. In other words, you get this list of things that you couldn't fit in there because they went somewhere else, and you have to either go in and add them and position that label where you want, or you have to get rid of it. And a lot of this is all off your annotation groups from your data frame properties. It saves part of the map. It opens the data frame properties to edit the annotation properties, such as the reference scale. And you can use remove group to get rid of annotation. Again, like I said earlier, you can store it in a database and it'll appear as a layer file in the table of contents. And if you want to get rid of it, you just get rid of the layer. Adding map elements. You can go off the insert and add your legends. There's a legend wizard. It's not the same thing as a wizard of legend like Dumbledore. So what you will do is go in and select the elements within the layers that you want to be included in the legend, give it a title. As a general rule of thumb, you should never call a legend, because if you don't know it's a legend, you're probably not going to be able to understand the map anyway. You can also, in the legend wizard, adjust a lot of things like the borders, the backgrounds, drop shadows, the gap, the rounding, and all these different things, and that'll help set up your legend. And set space between elements, usually leave it as the defaults, but you can adjust this if you see that it puts too much space or not enough, then by all means go in there and change that spacing. So just a couple styles here that you can see, a couple setups that are available. When you want to change things, you can click on the legend style and you can adjust it through any number of ways. You can go in individually and in the table of contents and change things. In the symbology properties, you can edit the descriptions. Scale bar, again, you go to the insert, you add the scale bar. Remember, it has division units, divisions, and subdivisions, and all these are determined by the settings, and you can go in and adjust those. Tell it how many divisions or subdivisions to have, etc. What division units and how do you want the labels and where do you want the labels at. When you options when resizing the scale bar, you can adjust the division number so that if you go so if the scale changes, so must the scale bar. Again, just a lot of different examples of the way you can adjust these things. And then there's north arrows. You can select any one of a number of ones simply off the insert tab. You can add the graticals as well with the wizard. And you can divide it by medians or parallels, and you can measure, there's just different ways you can do it, whatever sets up for the thing that you want. Text and titles, again, you can go in and add a title to your map or other text if you need to. You can insert pictures if you want an insert section to fill up some white space that shows some key element related to the data that you're trying to infer. And you can add neat lines. Neat lines are basically picture frame borders and lines that go around boxes of information that you have placed in your map to give it a more professional, more framed up sort of look. From graphics, you can add things like ellipses and circles and polygons and rectangles and various shapes, as well as text. You can adjust the font style, and there's all kinds of fill options as well. All those were from the Draw toolbar. When you're done and you start to review your map, print it, there's a couple of things you want to do. You can go to Setup and select the map that you want. Make sure everything's ready to print. And then a lot of times it's good to just crack at it and see what it looks like. You can export it as a picture file as well, so you can save it as a PDF or a JPEG or a TIFF or a GIF or any number of file formats, and then take a look at it. And a lot of times, if you're going to print a copy of a map to a bunch of people or to hand out or for some other purposes, the first thing you should do is save it as a picture file, and then open the picture file and make sure it still looks the way you want. Make sure your annotation didn't move around. Make sure that some of the dynamic sizing functions didn't jack your map all up. And then once you do that, you can, once you're certain that you're going to get a map that's shaped the way you want, then go back and print the map.